Hi team, today we are going to look at the Python SDK for Dataverse. We're going to cover off setting up our Python dev environments, we're going to showcase some of the methods available in the SDK, and we're going to point out some of the packages and resources available along the way to assist us in the development with this SDK. Finally, we will look at a basic agent, and hopefully that will spur some ideas that you can implement in your own projects. Microsoft have released the Dataverse SDK for Python in public preview as of the 3rd of December. The SDK reference can be found here. I will post these URLs in the video description. The most important part here is Dataverse client, which holds most of the operations in this SDK. This is the GitHub repo. There are some examples here. There's also some usual getting started stuff, but we will be covering most of this in this video. So let's get started with setting up our environment. If you already have your Python environment set up, please feel free to skip ahead. So first things first, we need to install Python. Go to python.org downloads and download the latest version. Install it. Also go to VS Code downloads and install VS Code for your operating system. I'm not going to spend a lot of time going through how we install these step by step. I'm sure that you can figure that out by yourself. We can install the Azure CLI, and we can authenticate through to our Azure tenant and then use those credentials in our Dataverse client when we want to interact with Dataverse. So the first thing we want to do here is set up a folder for our project. Navigate to a folder where you store your Python projects and create a directory here. Once we've created the directory, we're going to navigate into it, and then we're going to open this folder in VS Code. This will ask us whether we trust the authors. We do, because we are the authors. And here we have our folder open. We can see that it's completely empty folder in Visual Studio Code. Now let's zoom in a bit here and we will install our extensions. So if we go through to our extensions menu on the left hand side here, first thing we want to do is find Python by Microsoft here, and go ahead and install that. I already have it installed. The next is Jupyter. So we want to find Jupyter in here, and we want to install Jupyter as well. Find the Atom 1 Dark theme. This is going to get our text highlighting. Once that's installed, we can choose our Atom 1 Dark from here, and this will now set up our highlighting. Excellent. So now we want to change a setting in VS Code. So we will press Control and comma to bring up our settings menu, and we're going to search for Python terminal execute in file directory and make sure that this is ticked. Last but not least, we want to install UV package manager for Python. UV is the fastest way I've found to stand up Python projects, virtual environments, manage dependencies. It's a fantastic tool. I highly recommend that you use this as your Python package manager. To install UV, we will go back into VS Code. Let's just close out of all of these things and get back to our Solution Explorer and open up a terminal with Control backtick. And then we're going to run the command pip install UV. Once that's downloaded and installed, we can run UV init. Once UV init is run, you'll notice that there are a few files created here in the project. We have a git ignore file, we have the Python version file, a main.py, and project toml and a readme file. What we're then going to run is our UV sync command. And what this will do is set up our virtual environment. Here we can see our virtual environment folder. Another thing we want to do here is save our workspace. So we'll go up to our file menu here and we will go to save workspace as. This is going to save our workspace into our current project folder. So we can take a look at toml file here to see any dependencies, and at the moment we have none. So let's go ahead and add our first dependency. We will run uv add ipykernel to allow us to use the interactive terminal. Now we can look at our toml file and see that the dependencies are there for ipykernel. And if we look at our UV lock file, we can see that UV has actually tracked all of the packages and versions that are required to run this project. We need to make one more VS Code settings change. So if we hit Control and comma to bring up our settings menu, and we're going to search for Jupyter Interactive Window Text Editor Execute Selection, and make sure that this is ticked. Great, so let's test our first Python command. We will just close these down and head into our main.py file, make a selection, and press Shift and Enter, and this should now run in our interactive terminal. And here we have it, hello from Python SDK for Dataverse. We are all set up and ready to go. Let's dive into the Dataverse SDK. Okay, so if we open a new terminal here, make sure that you are in your virtual environment. And then basically we want to install two packages to allow us to use the Dataverse SDK. Those two packages are UV-add Azure-Identity and Power Platform-Dataverse-Client. So this will install both of these into our virtual environment. First thing we want to do is let's get rid of the terminal for now. So we'll just hide the terminal and let's get rid of this code here, and we will just clear our interactive. Get rid of the side windows so that we've got more real estate. Now we will import interactive browser credential from the Azure.Identity package, and we will create our credential using the interactive browser credential method. This will launch a browser with a Microsoft login prompt. Once we authenticate, those credentials will be used. If we were running this process from inside an Azure resource, the best practice is actually to use the managed identity credential, and we can set that credential up by passing in our client ID. Using a managed identity for authentication means that we do not have to worry about refreshing secrets. If we were going to be running this from a third party or an external server that's not running in Azure, we would want to use a service principal, in which case we could use the client secret and we could pass in our tenant ID, client ID, and the secret. To set this up properly, we need to create a .env file to store all of our secrets, tenants, IDs, goods, etc. So if we have a look at our project structure, we create a new file here and call it .env, and then we can populate our env file with tenant, client ID, and secret, as well as the web URL. Now, very important, we want to make sure that we include this in our getignore file. So if we go to our getignore file and we add our .env so that this does not get checked into source control accidentally. Next, we will add our package to manage our environment variables. UV-add .env and install that into our environment. So back to our main.py file, and we'll get rid of the terminal again. And now we're going to get our environment variables and read them into our client secret credential object. So firstly, we import OS, and then from .env, we import load_.env. Now we get our environment variables from our environment file using os.getEnv, passing in the key name and getting the values for each our tenant ID, client ID, and client secret to instantiate our client secret credential object. Now, obviously in a production environment, we would want to store these in a secure store like Azure Key Vault. Okay, so next we're going to get our base URL from our environment variables as well. We're going to import sys so that we can do some exit handling, and then we're going to get our base URL using the key. We're going to strip off white space and any trailing backslash into a variable named base_URL. Now let's create our Dataverse client. So we're going to import our Dataverse client from powerplatform.dataverse.client, and then we're going to create our client by calling the Dataverse client method, passing in our base URL and credential. Let's test our Dataverse client with a simple create call. So here we're going to use client.create. We're going to pass in the name of the entity type we want to create an instance of and the collection of properties that we want to set. So here we've got an account, and the name of that account will be Brett's Marvelous Coffee Limited. And here we're just going to print the ID of the created record, which is at index 0. We can now select our entire script and press Shift and Enter to run this in the interactive terminal. And as you can see, we get the GUID of the created record back. Finally, let's look at the last of our authentication methods. We're going to look at the default Azure credential method here. This method looks for credentials on your machine in a hierarchy. Firstly, it looks at the environment variables to see whether it needs to establish a service principal using a client secret and tenant. Then it will look to see if there are Azure CLI credentials. Then it will look for Azure PowerShell credentials, and then it will look for managed identity. Here we need to import our default Azure credential. Now let's test this method to make sure that the Dataverse client can still authenticate and create an account. Select our script, press Shift and Enter, and here we can see that we've got the GUID of the newly created account. Great, so let's start to explore what we can do with the Dataverse client. Firstly, we'll get rid of these comments, and let's just comment in here what we're actually done. So we've created a new account record. Let's create a new contact. So here we're going to say client create, passing in the contact entity and the properties of first name and last name, and then printing the GUID of the created record. Let's select this line, press Shift and Enter. And here is our created record GUID. Let's go and have a look at that record in Dataverse. If we refresh our grid, here we can see our record, Brett Ratty. Now let's go ahead and update that record that we just created. We're going to call the client update method, specifying the contact entity using the contact IDs returned from our previous create call. We're going to set the email address and the last name field. Let's select this and run. Shift and Enter. And now let's go and have a look at that record in Dataverse. Again, we will hit our refresh button, and now we can see that the last name has been changed and the email address has been set. We can also delete that record by running client.delete, passing in the entity type, and then obviously the GUID that we want to delete. Again, we can select this, Shift and Enter to run in the terminal. So if we navigate back to Dynamics 365 and we go ahead and refresh, we can now see that our contact record no longer exists. So we've looked at how to create records, update records, and delete records. Let's clear our session and let's have a look at how we can retrieve records. So we'll get rid of these here and let's have a look at our retrieve queries. This is a single read by ID. So we have a case ID and we've set the table name to incident, which is the case table in Dynamics 365 on Dataverse. And we are using the client.get method, passing in the table name, the case ID, and the columns that we want to be retrieved for that table. We're then printing out the response in a JSON dump. Let's go ahead and import our JSON. And let's execute our script. And here we can see our response coming back with our incident ID, and the title of that incident is Steam Arm is Broken. Next, let's look at how we retrieve multiple records. First, we will create our records collection variable, and then we will execute the client.get method, which takes in the table name that we want to retrieve from, a filter. We can have multiple filters specified here. In this scenario, there is just one where it is looking at the state code equals 0, which is active cases only. We are using the expand to select the name field from the associated account record of this incident. We are specifying a column collection of what we want to retrieve from the incident table, and we are ordering by created on date descending. We are then retrieving the next page in the records.extend. Finally, we are going to pass that record collection into a pandas data frame. So we want to install pandas. So if we go back to our terminal and run uv add pandas, making sure that we are in our current environment. And then we want to go ahead and import pandas as PD. Here we can get rid of our terminal again. Now let's go ahead and run this query. Now that the result set is in a pandas data frame, you can use the pandas API to play around with your data. You can find a cheat sheet on the pandas.pydata.org website. Pandas has a very rich API, and there is a lot that you can do with it. We won't go into this in detail in this video, but I highly recommend that you explore this. Let's run a few of these data frame methods so that we can interrogate our result set. So the first thing we want to do is print df.shape. And this is going to give us dimensions of our result set. So we'll shift enter this and we can see we've got 21 rows and 8 columns. Let's try print df.info. Here we will see the info for our result set. We can see our range index, 21 entries. We can see that we have 8 columns. We have our column names, our non-null counts, and our data type. We also see the memory usage. Now let's run df head and get our top 5 records here. So we can see our description, our incident ID, customer ID value, title, and created on. And then we can see our expand table actually getting the customer ID accounts out here. To get to the actual name field, we can reference our customer ID underscore account in our data frame, use the string.get to get the name out of it. Shift and enter, and we can get all of the names for the accounts associated to our incidents, our cases. We also have the ability to query via SQL. Here we can create a normal SQL query, select top 10 incident ID, title, status code name from the incident where state code equals 0, order by created on descending. We can then use the client.query_SQL and pass our SQL statement in, and eventually send the result set to a pandas data frame. We can then use the pandas API again to run the info command to analyze our result set. Shift and enter, and here we can see we have 10 entries, our columns, our non-nulls, and our object types. Note that SQL support is limited to read-only queries. Complex joins, subqueries, and certain other SQL functions may not be supported. We can also create tables, update tables, and delete tables in Dataverse using the SDK. We'll have a quick look at the syntax of what that looks like here. So we can create a table where we set up our enums for our status. We've got active and archived. We set up the solution name that we have in our Dataverse environment that we want this table to be created in. If we don't specify a solution, this will end up in the default solution. We then give our table a name. We do have to put the custom prefix in our table name, then provide the column names with the prefix as well, and the types of each of those columns. We then call the client.createTable method and pass in our table name, our columns, our solution name, and what we want our primary column on that table to be called, obviously also including the prefix. We can also add columns to an existing table by calling the client.create_columns method, passing in our table name, and then a list of the columns and data types. We can also remove a column by using the client.delete_columns method, passing the table name in, and then a collection of the names of the columns we want to delete. We can also delete an entire table by using the delete_tables method. Be careful with this one, you cannot reverse the deletion, and all data in that table will also be deleted. Now that we've covered off some of the basics of the Dataverse client class, by all means not an exhaustive list, let's have a look at a practical implementation of what an agent might look like using this SDK. But firstly, I'd like to draw your attention to the awesome GitHub Copilot instructions for the Dataverse SDK for Python Agentic Workflows guide. There are quite a few instruction files here for Python SDK for Dataverse. This one in particular outlines the Agentic Workflow guide. Note that it is in preview and many of these patterns could change before GA. Have a read through this file, and at the very bottom you will find some of the frequently asked questions. Have a read through these. There are some things to note here that MCP and A2A are coming in GA, but are obviously not there in support at the moment. Microsoft are positioning the Dataverse SDK for Python to be the go-to platform for building intelligent autonomous data systems on the Microsoft platform. This is important to know from an adoption perspective for picking this up and running with it. I'd like to give a big shout out to Troy Simeon Taylor from Microsoft here. He's put a lot of effort into getting these instruction files up here for us. So let's have a look at a proof of concept agent that I put together, utilizing both the Python SDK as well as Azure OpenAI and GPT-4 model. The first step is obviously getting some data from Dataverse. This is actually from a case management system, so it's collecting case records. First, our Python agent connects to Microsoft Dataverse using the Azure Identity Library. It pulls some of the raw case data in, which are specifically incident titles. The data is then ingested by our Python class, and it acts as a bridge, formatting those raw records into a prompt. The agent then sends this prompt to Azure OpenAI, specifically the GPT-4 model. The LLM performs semantic analysis. It groups similar customer complaints together by looking at the semantic meanings of the titles of those cases, and then returns a clean JSON object. Finally, the agent passes that JSON into a pandas data frame and renders a horizontal bar chart, giving a visual summary of the top support issues without manually sorting through them and trying to group them. So let's do a quick dive through the code. Usage is that we instantiate our analyze cases agent class. We call our agent analyze cases method. We pass in the table incidents that we're trying to retrieve and the sample size of 25. We then read the result sets back into a data frame, and we call our visualize problems method to create our visual of that data. Let's have a look at the analyze cases agent. The init class is responsible for loading the environment variables, checking that all of the environment variables that are required to run this agent exist, creating the credential objects for both Python SDK for Dataverse, as well as the OpenAI client. The analyze cases method retrieves the raw data from Dynamic, selecting title from the table name of incident and limiting that to the sample size passed into this method. It then constructs the prompt using the returned data records and defines a distinct JSON response structure. The prompt is then sent through to the Azure OpenAI client chatCompletions.create to the GPT-4 model. The model's response is then validated as JSON before being passed to the pandas data frame. The visualize problems method is responsible for rendering the horizontal bar graph based on the data frame that is passed into it. Let's see this agent in action. And here we can see the rendered horizontal bar graph. We have problems and a problem count. These are semantically grouped based on all of the titles of the cases that were retrieved, and we have a good breakdown of our most common problems raised by our customers. This is a very simple agent, but it gives you an idea of what you can do, and now it's up to you to go and play with it. And that's a wrap for now, team, so thank you for joining me. I really appreciate your time. Please like and subscribe, it really does help the channel, and I'll see you on the next one.